Welcome to the Quick Start video for Unit 10 to explore radio communication. Here's what we'll cover. We'll introduce the learning goals and featured computer science concepts. We'll call your attention to important preparation, including optional materials to play sound in lessons B and C. And finally, we'll summarize each lesson's main activity, focusing on an unplugged activity in lesson A called Hot and Cold. Feel free to have the unit materials open as you watch, so you can pause at any point to look at them in more detail. Now, during this unit, students will understand how to use the radio blocks in MakeCode to send and receive data between microbits. They'll understand the different types of data that can be sent over radio. And finally, they'll work in pairs to design a unique program that uses radio communication. Now, you likely think of a radio as an object that you listen to, but radio also means sending electromagnetic energy as waves from one place to another without using a wired connection. And so in simple terms, the equipment that sends out a radio wave is known as a transmitter. And the radio waves fly through the air, even great distances, and the antenna of a second piece of equipment, which is called a receiver, captures certain radio waves as they pass by. And so which radio wave the receiver captures, it depends on the specific wave speed, the length, and the frequency that receiver is set to receive. Now, you may have noticed a wavy line on the back of the microbits. This is an antenna that allows Bluetooth and radio communication between microbits, with one acting as a transmitter and the other as the receiver. And depending on which group you set each microbit to transmit at, you can have pairs of microbits transmitting on one group, and other students at the same table will set their group to a different ID, and so the radio signals won't be intercepted by each other. Now, like the previous unit, there are links to articles, and there's a video in the recommended resources for additional support with these concepts for yourself and to share with your students. Now, for the unit level preparation, you'll have the typical steps of reviewing materials and practicing all activities. And during the unplugged activity in lesson A, your students will probably need some space to move around as they play a game to experience the radio functionality. Outdoors is great if you can do that, or if your classroom isn't big enough to have the pairs of students working with each other and moving around, you might have to arrange for a larger area. Now, for lesson B, there is a mod option for the Marco Polo coding activity that uses sound. So microbit versions 2 and beyond, they have a built-in speaker. But if you have the original microbits, then the links to the tutorials to connect headphones to the microbit, we provide those again for easy reference. And if you decide to do that modification with your students, and it's a lot of fun, you'll want to have some additional materials for sound available if you've got the original microbits. And then for lesson C, you'll just want to review the note about pair programming. And you'll want to decide how you're going to pair students for the project so that they can be seated together. Sometimes it works well to have students choose their own partners. Sometimes it works better for you to make the pairs, so you know your students better. But you'll want to decide ahead of time how you want to pair them up. And again, similarly, if you're going to provide the option for sound, you're going to need to have materials ready in addition to the usual crafting supplies. If you're using the original microbits that don't have a speaker built in, you can connect them up to a set of headphones. So now in lesson A, your students will play a familiar game called Hot or Cold as a way to use two-way communication to locate a hidden object. And now the way it works is the students are going to work in pairs, student A and student B. So student A picks a secret object somewhere in the room, but doesn't tell student B where it is. And then student B takes a step in any direction and calls out check. Student A is going to respond with hotter or colder, And you can keep going with student B calling out check and student A responding with clues to find the hidden object. And then you have the student switch places. Now with lesson B, there are two coding activities. The first activity is coding a version of Marco Polo that sends and receives string data between microbits. And again, if you decide to set up the headphones to have them work with headphones, you're going to need crocodile clips. And you'll have to demonstrate that. So now the second activity is called Morse code. And the idea is you are using the microbits to send and receive numeric data to simulate Morse code. And again, you'll want to set the group ID so that the student signals don't conflict with each other. And then finally, for lesson C, you're going to start with an overview about pair programming. And then you'll want to share the partner assignments. And then you'll explain the project expectations of collaborating to design a project that uses radio communication to send and receive data in some way. Now, there are two different project ideas that you can share with them. One of them is called Stop Thief, which is the always popular bedroom alarm. In case somebody goes into your room, you'll set an alarm off. And interactive art is another one. And there are two project examples that you can show them. One of them is a very simple sort of 3-note keyboard. And the other one is a radio tennis game. And that's it. This is a really fun unit, and it has students working with each other throughout. Have a great time.